Hello everybody and welcome to CCNA Scaling Networks version 6. This is chapter 2, Scaling VLANs. One of the critical factors for any sort of VLANs is being able to have those VLANs in multiple places. So VLAN trunking protocol is the protocol specifically designed to allow switches to learn about VLANs and their characteristics. So it's a bit interesting because Cisco a few years ago actually said that VTP is too dangerous, and we'll talk about why that is in a moment. So they say, you know what, if you've got 500 switches and you want to make a new VLAN, well then you have to make that change 500 times. But there are still people who still like to use VLAN trunking protocol because it means when you've got 500 switches, you just go to a switch in your network, the server switch, a switch that you trust, and you say here's a new VLAN, and then within a few seconds that VLAN exists everywhere where you need it to exist. So VLAN trunking protocol is a protocol specifically designed for switches to share information with each other. So you go to the, like for example here, we've got a switch down the bottom, we add a VLAN, the VTP shares that new VLAN information to the other three switches within that VTP domain. VLAN information is restricted to a single VTP domain. It really helps you with configuration, but of course if you make a mistake, that mistake will be replicated everywhere. You can have a setup where some of the switches in your network do not learn via VLAN trunking protocol, and we'll look at that in a minute. But you've got to be really careful because you can also, if you misconfigure your VTP or leave it on the defaults, someone can actually inject information into your VTP domain that you don't want. The revision number is a critical factor as well, because if you get a switch that has a higher revision number than the current server or the current switch that's the boss of your network, and you plug that into the network, and if it's got the same name and there's no sort of password, then that switch can actually overwrite your entire network with wrong VLAN or bad VLAN information. So VTP is an awesome tool, but there are some cautions when you need to think about when you're using it. So let's have a look at VTP. Three main modes. You've got a server mode, and the server can add, modify, delete, rename, all the things you'd expect a server to be able to do. You have a client. Now the client can only learn. He can learn from the server, and he can forward VTP messages between two other switches. And the final one is transparent. Now the transparent will forward VTP messages from switch to switch to switch, but he will not learn. He will not learn new information, and he will not teach other people information. He will just pass, this switch, transparent mode will just pass VTP information on to the next switch. Now, VTP it exists in the native VLAN. It must exist in a trunk. It can only exist in a trunk. And it can be either in an ISL trunk or an 802.1q trunk. VTP messages types. You have an advertisement request saying, hey, I need some stuff. Please tell me what you've got. You got a summary. You know what? Oh, look, every 5 minutes we're going to send you out and say, guys, are you all up to date? This is the current revision number, and if you're not up to date, let me know, and I'll give you the information you need. And so, if you're like one revision behind, then a subset advertisement will say, okay, you know, here's what's changed since the last update. So, you don't have to receive the entire VLAN table if you're only just one revision behind. So let's have a look at what makes this most important. Here we've got a server, we've got a client, and we've got a client. And we've got an 802.1 trunk between them. They're all happy. They're all talking together and they're all happy. Here we've got a server, a server, a server. So all three of these switches can add, remove, delete, whatever they want to do, and everything's fine. And by the way, all switches are server when they're factory default. But here we've got some problems. We've got a transparent switch, we've got a transparent switch, and we've got a transparent switch. So these three switches have all been configured manually with the VLANs. 10-20-30, 10-20, 10-20-30. But this poor guy over here, he's not getting any love. Here we've got a server, we've got a transparent, and we've got a client. So he's got 1020/30. The server has pushed through the transparent switch towards the client, so the client has learnt 1020/30. But the middle switch is transparent and he's only got 10 and 20. But once again, this poor guy over here on VLAN 30, he doesn't work. The solution to this problem is actually the same. So technically, yes, you could set this to client and this one to client, and that'd be fine. But there's another thing you could do, because what's happening here is that VLAN 10 traffic comes in here and it's tagged. Your VLAN 10. It gets the switch says, oh, VLAN 10, I know what to do because you exist. VLAN 20 traffic comes to the switch, oh yes, I know what to do because VLAN 20 exists. But when VLAN 30 goes into the switch, it says, VLAN 30. I'm going to tag you as VLAN 30. It comes along this trunk, goes into the switch, this switch says, well, VLAN 30 doesn't exist. So it throws in the bin. And this is a very common thing you'll find when you're setting up VLANs in transparent mode, that it's not going to you need all VLANs here. So the solution to this problem is to put VLAN 10 and VLAN 20 and VLAN 30 all. So how do we actually program VTP? We configure terminal, we go to VTP mode server, or client, or transparent. Note the prompt is still global config. We set up a domain name, because the default name is just empty, and it's basically listening for any VTP information and will just take on the responsibility of what it learns. So set a domain name for security. Then we set up our version number, optional. Password is optional, but strongly recommended. And pruning is an extra feature we'll talk about later on. Once again, a reminder that VTP messages can only exist inside a trunk. If you are reading older material, you'll find that they'll talk about creating VLANs in a different style. And this is the old school, or the classic, where you type the command VLAN database, and then you get a whole new prompt. You set up your VLANs, you set up your domain name, you set up your password, and you must click exit or apply. If you just do Control Z, everything's lost. Now the thing with the VLAN database, you could go in there and you can make 50 changes, and then you click apply, and that will only increment the revision number once. But it's also not saved in the running config, so it's very hard to script and see what you've done. Whereas the new school, the current way we're doing it, is all in configure terminal, all in global config, or the VLAN config, and it all appears in the running config. So when you do a show run later on, you're going to see the VLANs, their names, the server mode, all that sort of stuff. Just a bit of a caveat there that you can only have one VTP domain per switch, and each switch can only be part of one VTP domain. So let's just a quick refresher to make sure we understand what 802.1q tagging is all about. We've got our original frame, we've got our destination to source MAC addresses, we've got a type length field, we've got our user data, and we've got the frame check sequence. So we maintain the MAC address pair, we maintain the type length field, we maintain the data, but frame check sequence thrown in the bin. Now we insert our tag, and the tag has the priority, 3 bits for priority, 1 bit for whether or not it's token ring or not, and then 12 bits for the VLAN. So VLAN can be numbered up to 4095. This is now bigger. So what's the maximum frame size now? Hopefully you all just shout at the screen what the maximum frame size is now. It's now 1522 because the default maximum frame size is 1518. And now we have added more into it. So now it's 1522. The reason why this is important is because if you're on an interface and it's showing lots of errors and those frames are erroring out, are being marked as giants or jumbos, it means they're too big. So the other end wants to be a trunk and the end you're plugged in isn't a trunk. So that's why frames that are tagged, that are the full size, will be discarded if they're not going towards a trunk port. Now, dynamic trunking protocol is really useful, but it can cause some trouble. For example, we've got a 3550 on the left and a 2950 on the right. A 35, 36, and 37 all want to be distribution layer switches, whereas a 26, 27, 28, 2900 series all want to be access. So you plug two access switches in together, they want to be access mode. You plug two distribution switches into each other, they want to be trunk. So when you plug an access into a distribution, you're never quite sure what you're going to get. So dynamic trunking protocol is a way of negotiating whether to be a trunk or not. So here's a bit of a matrix. So if everything's on auto and nothing's set, they should become access. If one end's desirable and the other end's auto, it'll become a trunk. Both ends are desirable, it'll become a trunk. If you force and lock it to be trunk, it'll become a trunk. If you force to become access, it'll become access. But what happens when you have one end force a trunk, one end force access? We don't know. Bad things will happen. Now, if security is your number one most paramount thing, you can actually turn off dynamic trunking protocol. And the command is simply switch port, no negotiate. When you're setting up your switching and your inter-switch connections, newer switches, more powerful switches, support two types of encapsulation. They support the original Cisco proprietary ISL or inter-switch link and the open standard of .1Q. However, on the layer 2, the mid-range switches, the 2900 series switches, they only support .1Q. So you type the command switchport trunk encapsulation .1Q, you get an error because it doesn't actually support multiple encapsulation types. However, if you're on a 35, 6 or 700 switch and you just say switchport mode trunk, it'll give you an error because it'll say you have to tell me the encapsulation type first. So it's a good best practice just to type switchport trunk encapsulation .1Q, and if it takes, good. If it errors out, you can just move on. It's not the end of the world. So show interface trunk, really good command to see which ports are trunking, and also show interface switch port. It's also another useful command to see what it is doing. It's access, it's trunk, what VLANs are on it, all that sort of stuff. Things that make a trunk not work. 99% of the time it's either not configured or native VLAN. Native VLAN mismatch is going to be a big problem, and we'll look about moving the native VLAN in a little while. And of course encapsulation. You've got to have them both ends ISL or both ends .1Q. .1Q is pretty much the standard now. ISL pretty much phased out. So we'll do a bit of a quick Q&A just to see that we're on the same page. So here's a classic example of a show VLAN. Show VLAN, this is the output. How many VLANs are there in total? Hopefully we've all shouted at the screen that there are 10 VLANs in total. Now, how many VLANs have we created? How many VLANs have we actually gone to the trouble to create? The answer is 5. 5 VLANs. VLAN 100, 150, 160, 200, and 555. VLAN 1 and the 4,000 VLANs are there by default. They're burned in, you can't change them, can't get rid of them, they're there forever. Is there anything wrong with a marketing VLAN? Look at the marketing VLAN. Is there anything wrong with it? No. There just happens to be no interfaces currently associated with it. If I plug this is just a switch by itself, and I plug a PC into port 3 and a PC into port 16, can they see each other? Can they communicate with each other? Port 3 and port 16. The answer is yes, they're both on the sales VLAN, so everything's fine. Now, trick question, which ports are actively trunking? So pause the video and see which ports are actively trunking. Not as obvious, but ports 23 and 24, because when a port is actively trunking, it's not a member of one VLAN. Therefore, when you say, hey, show me all the ports that are on what VLAN they're on, it won't show up. So if you look up there, ports 23 and port 24 are not listed, so therefore they're actively trunking. But if you unplug the cable on port 23, so it goes down, it'll show up on VLAN 1. And then when you plug it back in, it'll disappear again. Now, here's a very important question, and this is in the chapter exam and also probably in the certification exam. What would happen if I delete VLAN 200? So VLAN 200 exists, and there's port 4 and there's port 5. What would happen if I just went to the switch and said, conft no VLAN 200, enter? The answer is that port 4 and 6 would just go down. They'd not be there. There's no default. They won't magically move to another VLAN to try and help you out. If you've got ports on a VLAN that doesn't exist, those ports are as good as shut down. You plug something into port 4, nothing will happen. And in fact, on the newer switches, the LED indicator just glows orange to show you that there's nothing happening on that interface. Extended VLANs. So, between 1 and 1005 are normal. Extended range are between 1006 and 4094. VTP doesn't learn about extended VLANs. So if you want to make some magic extended VLANs, then you have to create them manually. So the best practice for extended VLANs is to make that switch transparent. Because if you're going to use extended VLAN numbers, then extended VLANs are what you need to use. Now, troubleshooting. Incompatible VTP versions, so just leave it on default by default. Passwords. Passwords are domain names. This can be your savior, because if you've got a switch, let's say you set up a network with 5 switches and everything's going perfectly. You've got 20 VLANs and everything's going great. And then there's a sale on eBay and you buy a switch and you bring that switch into your network and you erase the config, but the VLAN database is still there and you've plugged it into your network. Now, who knows how many 100 VLANs and how many times that's been modified on that switch. When you plug that switch into your network, because it also has the default domain name and password, but if it's got a higher revision number, it will actually overwrite its VLAN information over the rest of your other 5 switches. So that's why the very first thing you always have to do is set a domain name away from the default. Because the default is either empty or Cisco. So give it a name that makes sense. And give it a password. And that way no one can actually inject bad VTP information into your network. And you might think to yourself, well, Josh, that VLAN, that revision number thing seems like a huge mistake. Well, just imagine you've got 5 switches and the server dies. So all you're left with is 4 clients. When you replace that server switch with a brand new switch with a blank configuration, you want that switch to be able to learn from the clients. So any switch with a high revision number that has the same domain name and the same password, whichever switch has got the high revision number will overwrite the VLAN information of the one with the lower revision number. And that's by design. So, what is inter-switch VLAN routing? Let's have a look. Nothing wrong with this at all. We've got 2 PCs, we've got a switch, we've got all this lovely thing set up here. So we've got PC 1 is on VLAN 10, we go in here on VLAN 10, we come out of here on VLAN 10, we go into this router on whatever network it is, 172.17.10, we get routed, we come out at 172.17.30, go into here on VLAN 30, come out of here on VLAN 30, everything's fine, everything works. However, what happens when we want to add VLAN 20? What happens when we want to add VLAN 50? We're going to chew up unnecessary ports between here and here, and that's going to cause a lot of, so it's expensive. Multi-port switches, not that much. Multi-port routers, very expensive. There's nothing wrong with this, and it works, but this is a much more common and much more interesting router on a stick. So we've got PC on VLAN 10, it goes into the switch on VLAN 10, it goes to the router on a trunk, it gets routed, it comes out on VLAN 20, it goes back along the trunk on VLAN 20, and then it leaves the switch on VLAN 20. Router on a stick, so fewer ports are used because it's a single trunk. The switch must support VLANs, must support trunking. The router must support sub-interfaces and added 2.1q encapsulation. But all the VLANs are on a single interface. So if that's only a 100 meg interface, a couple of VLANs, no problem. You put 50 VLANs on there, that link is going to get pretty tight. So either have a gig or something better. So let's have a look at how to actually program this. So we have, this is on the left, we have the switch config, and on the right we have the router config on the left and the switch config on the right. So the very first thing we need to do is enable, with no shutdown, the major interface. Then look at here, First Ethernet 000.10, encapsulation.1q 10, IP address 172.17.10, 10. Now, the fact that this is 10, this is 10, and this is 10, that's not a rule. That's just a very, very strong guideline. Because yes, this could be subinterface 1, yes, this could be VLAN 64, and yes, this could be 172.17.99. whatever. That will work, but it's very confusing. You want to come back in 6 months and say, oh, VLAN 30, oh, that's subinterface 30. VLAN 30, subinterface 30. Oh, and it's 172.17.30. Have some sort of correlation, have some sort of pattern. Now over on the switch port mode trunk, switch port encapsulation.1q. Those commands should be reversed, but never mind. So you need to set up the encapsulation type and make it a trunk. Not such a bad idea. Full duplex 100, full duplex 100. Now, port 6, VLAN 30, port 11, VLAN 10. This is a working config. Now I've got this command, switch port trunk native VLAN 10 in purple, and this command in purple as well. They have to match. So you either have them both, or you don't have anything at all, and just allow the native VLAN to be 1. Remember, the native VLAN exists for traffic that cannot be tagged. So all traffic in the native VLAN is untagged. So if we say encapsulation.10 native, that means it won't actually be tagged. So it'll come from the router and enter the switch untagged. So we need to also declare which is natively tagged. So two methods of thought there. Either leave all your native VLANs on VLAN 1 and don't use VLAN 1 for anything. Nothing at all. Or pick a VLAN like 99, a lot of the labs are 99, or 555, or any number you want, but don't use it for anything. So always make the native VLAN a VLAN that no users exist on. And remember to create a subinterface. However, if you can afford it, another good thing you do is buy a layer 3 switch. So now we've taken the router on a stick philosophy and put it into a single chassis or a single case. So now I've got a few, so you've got VLAN 10 and VLAN 20 are the layer 2 components, and then they're routed up into a router to do all of the routing at layer 3. So the first thing we need to do is turn on IP routing. That actually takes your layer 3 switch and enables layer 3 functionality. Up to this point, all layer 3 switches are shipped as layer 2. So you have to actually turn on layer 3 routing. And then we'll just set up virtual interfaces. IP address VLAN 10, IP address interface VLAN 20. These are now 2 layer 3 routing interfaces. A switched virtual interface is a layer 3 interface. Can be set up for any VLAN. It should be the default gateway for all traffic users on that VLAN. A VLAN cannot have more than one SVI. If you've got VLAN 10, you can't make, interface VLAN 10 and interface VLAN 20 both being on VLAN 10. It doesn't work. Also, switched virtual interfaces do not support sub-interfaces. But they do not need to be explicitly configured for all VLANs. So you could have VLAN 10, 20, and 30, but on this particular switch, it's only routing for VLAN 10 and 20, and someone else is routing for VLAN 30. But you cannot have sub-interfaces. You cannot have interface VLAN 10.1, interface VLAN 10.2. It physically does not work. And this comes back to our lovely 3-layer model, core distribution access. The old school days was to have a pure layer 2 core. But now, for better redundancy, because the routing is much more efficient, they want a layer 3 core. Now, you can either use VLANs and route into the core, or you can literally just come to each of these interfaces, this one, this one, this one, and this one, and this one, and this one, and actually make this a pure layer 3 routed connection. And the way you do that is you just go into that interface, notice we're in interface mode, and just type no switch port. No switch port literally just disables all layer 2 functionality. It's not a trunk, it's not access, it's not anything like that anymore. It is a pure layer 3 interface, separate from all other interfaces. So, what do we look at today? Troubleshooting. Troubleshooting layer 3 switch configuration interviews. Make sure the VLANs are consistent. Make sure the switch virtual interfaces have the correct IP addresses and subnet masks. Make sure routing is enabled. Make sure you need a routing protocol. Make sure the hosts or PCs actually have the right default gateway. Super important stuff. And just like we looked at before, server, client, transparent. If you've got transparent switches in the middle, make sure they've got all the VLANs. Because switches need the VLANs to be able to move the traffic through them. Alright, thank you very much.